Good evening, everyone, and welcome to Sky Observers Hangout. We are so happy you are with us tonight. Hello! And my name is Michelle, and I'm the Director of Public Observing here at the Adler Planetarium, and I have a friend with me right here.
Yes, and my name is Hunter, Public Observing Educator here at Adler. We are so glad that you all are joining us today. It's an exciting night. We've got lots of observing here going on YouTube, but also some observing going on here in the building at the Adler today. So it's an exciting night for looking up at the sky, isn't it?
Yeah, absolutely. Now, Sky Observers Hangout is a place for us to all gather together to nerd out about the sky. If you want to just sit back and watch, that is perfectly okay. If you would like to interact with us in the chat, that is wonderful. Please do that. We have the chat going right now, and I know a bunch of you are indicating where you're from. Keep doing that, and we'll do another reminder in just a second. If you want to ask us questions, please do. We're going to tell you about our friends who are behind the scenes. You want to tell folks about who's there helping us out?
Absolutely. So here in the YouTube chat tonight, we've got Jennifer helping out as chat moderator. If you see the Adler Planetarium's name highlighted in the chat, that's Jennifer. She'll be passing any questions that you have along to us this evening. And then if you also see a name with a blue wrench next to it, that is our wonderful astronomer friend and coworker, Geza.
As in Stargazer.
Yes, Stargazer. Not gazing at any stars tonight, but close enough, close enough. So he'll be helping us in the chat, answering some of your maybe more difficult questions or ones that require a little bit of a more long-form answer, right? So thank you for helping us out, Geza, and thank you for providing all of your wonderful knowledge to the folks in the YouTube chat this evening.
And hey, by the way, if you're joining us from home, just want to let you know the Adler Planetarium is open for visits. Jennifer is going to put a link to purchase tickets if you want to in the chat. So hopefully you can come and see us in person one of these days. But why don't we see where some of our folks are from? Continue to please let us know, where are you tuning into? We're going to say hi to a few of you right now.
Yes, let us know where you're coming from in the chat. We've got representation from many different states, it looks like today. Good Midwest representing here, from Michigan, from Iowa, and lots of folks from different places in Illinois today. I see Waukegan, Chicago, of course, as expected. Some Kenosha, some Schaumburg in there. Someone in the Rush Hospital ER right now. So
hey, Rush
hope
Hospital
that means
ER?
Things are going well there in the ER at least. And thank you for joining. We had one particularly special shout out we wanted to give Michelle.
Yeah. Hey, we have a special group of folks we want to say hi to tonight. We want to say a special hello to our friends at the Farmer's Almanac. It's so great to have you with us, and all those who might be joining us via farmersalmanac.com. Almanacs have been used for so long for folks to be able to look up at the sky. So it is a lot of fun to have those friends.
Yeah, and some almanacs might come back up later in the show as we're thinking about our observing targets tonight.
Yeah, and I'm seeing we got folks from Georgia, Texas. Hi, Bob in Mokina. We know you're there. From Schaumburg. So we got a whole lot of folks. But let's get on to the moon. That's why you're here.
Well, we all know what we're here for. It's the name of the show tonight, right? This blue supermoon. So I think number one priority is getting us to the telescope view. So you might see Michelle come in and out every once in a while tonight.
Yep. The telescope is over there. So I need to leave the seat, go over there, get it pointed at the moon. Stay with us. Hang on.
Oh, yeah, absolutely. So I will make sure to keep everybody nice and entertained over here. You should still be able to see Michelle from the other side. And let's switch us over to this beautiful view of this full moon that we have going tonight. Now, just as a reminder, if you have any questions tonight, feel free to drop those in the chat, whether it be about the moon that we're looking at or any other questions you might have. Things always come up, and we're happy to give some answers.
This is a live view of the moon. We've got a telescope pointed at the moon tonight. And if you see it moving, that's because the telescope stays pointed in one direction and the Earth does the turning. So it makes the moon appear to move across the sky. So our telescope is not tracking the moon. So I have to go over there every few seconds or so and turn it just so we keep it nicely pointed at the moon. But yeah, we've got a really great telescope and a camera pointed at it right now. So I hope that this is showing up really well for you.
So I figured, starting off today, since we are observing this beautiful full moon, and we have, some kind of unique words in the title describing this moon today. That maybe that would be a good first thing to cover for the evening. So first, I think it would be good to talk about this idea of a supermoon and that concept, because I think that one's a little more straightforward than the other one that we have in here. So can you tell us a little bit about what a supermoon means?
Absolutely. So a supermoon refers to the full moon being nearest when the moon is closest to the Earth. We have a special term in astronomy for that. We call it perigee, P-E-R-I-G-E-E. G means geo, Earth. Para means close. So when the moon is at its close point to the Earth, and this refers to also when this is at full moon or around the time at full moon. There isn't a strict scientific definition for this word supermoon. It just kind of came about for people using it maybe about the last 10 years or so. It's a relatively new term. So there's no science definition that we're following for this. And so it's not like the moon needs to be within a certain distance or anything like that. So when the moon is at its close point, and it refers to full moon, because that close point can occur at any point in the moon's orbit around the Earth, but in this case, it refers to full moon. And so that means the moon might appear a little bit bigger. Maybe. You may not notice the difference.
It's a pretty fine difference. So
yeah.
I can pull this image up that I had really quick. So this image is comparing a moon at perigee versus a moon at apogee, right? So these two terms that describe perigee at its closest, right, and apogee at its most distant point in its orbit. So these will be the different sizes at those two extremes, right? So you can imagine that the average size of the moon kind of being in between these two, it might be a little more difficult to tell the difference between them. I think the size difference is only about 12% difference between perigee and apogee. So you can see here, when they're right next to each other, it's quite obvious. But, with it just up in the sky, it can be a little bit tougher to tell. The orbit is still mostly very circular.
Yep, exactly. So the difference in size may not be readily apparent. What you might notice maybe is a difference in brightness. If you happen to notice the moon is a little bit brighter than normal, that might show up. I need to go move the telescope again. Hang on.
Yeah, look at how quick that thing moves. How quick we spin around. So, the brightness is something that you can notice a little bit more. When at perigee, when at these closer points, it can be upwards of like 30% brighter than when at apogee, when it's more distant. So that can make a decent difference, honestly.
Yep.
That 30% difference is probably a little bit more noticeable than the 12% size difference.
Yep. So, by the way, we want to say hi to someone. We know that there are several of you just watching for fun. We know there's someone out there watching for science and for school. So John Weber, hi, you're a sixth grader in Wheaton, Illinois. You're watching for your science project, so we know you're here. So thanks for checking in with us. I hope
the science project goes well.
I hope
this is a good start.
Hope you get an A. So anyway.
If you have any questions, drop them in the chat.
Let us
know. We can totally help.
All right. So, but we know the question is also out there. Why is this called a blue moon? I'm looking up at the moon and it's not blue. What's going on? All right. Let's explain. Let's talk about that term blue moon.
And it's got a fun history behind it too.
It does.
So I like this little story here.
Yeah. So the term blue moon originally just meant something completely nonsensical, something just nonsense phrase, just something that just would be so absurd that it would never happen. Then it kind of it morphed into a phrase that just meant something that just doesn't happen all that often. All right, so something that maybe is kind of rare. In the 1800s, the Maine Farmer's Almanac, which doesn't exist anymore, but the Maine Farmer's Almanac.
Just to make it clear, this was a little confusion we had earlier, and I was talking to some other people. Maine, like the state Maine.
The state Maine.
Yes, Maine
Sorry.
with an E.
Yes, Maine is referring to the state. The Maine Farmer's Almanac in the 1800s declared that the blue moon phrase meant the third full moon in a season where you get 4 of them, because most seasons have 3. And sometimes, because of the moon's orbit around the Earth, it doesn't line up with our sun-based calendar all that much, or all that great.
So sorry to interrupt. You can totally see the fireworks through the window behind us right now.
Oh my goodness.
That is a funny one. Look at them back there. Those are good. Those are logic from Navy Pier right now.
If you're wondering if we're live, we are actually live. Anyway, sorry.
Back to the astronomy.
We get amused very
easily distracted.
So the third full moon in a season that features 4 of them. Okay, that's confusing. Now, in 1946, I believe it was May 1946, Sky and Telescope magazine had an article that misrepresented the definition of a blue moon. And they took that Maine Farmer's Almanac definition and morphed it to say the second full moon in a calendar month. So if there was a full moon at the beginning of the month, if the month lasted long enough, so 30 days or so, then by the end of the month, you would have enough time for the full moon to come around again so you could see it.
Right. So we have a great example today, right? The 30th of August, we've got a nice long month. We had a full moon right at the beginning of the month.
Yep.
And so we're getting a second one here. And you can see where the confusion would have come up, right? They are both referring to an extra moon occurring during a certain time of the year, right?
Correct.
But nowadays we use that term, more specifically with the 2 in a calendar month.
Yep.
So it's a term that's shifted over time a little bit.
So does it refer to color? No, it does not. The moon is going to be its normal color. You might see it a little yellowish where you are. That's kind of because it's taking kind of a low path through the sky. So you're looking through more air. And when you're looking through more air, the light is scattered by our air, scatters out the blue colors first, leaving you with the more yellowy colors. And so that's why it'll look probably a little bit yellow for you tonight.
Fix our telescope.
I'm going to fix the telescope.
Right. Yeah, I know it's going to be a constant battle tonight.
So it's okay. And so if you're noticing the moon going backwards, that's literally me turning a knob to get the telescope back to where it was.
We also have a 5th grader joining us here today, too, who learned about this in school today, Ralphie from Ordinary. So thank you for joining us today as well. That is wonderful. Now, I did want to say there have been a few instances where people have seen a moon that did look blue. So there are some rare conditions that can cause it to appear blue.
Yes.
It's happened usually when there's a lot of particulate in the air, right? I think in most cases it's been like near a volcanic eruption, right? So you may see some images online that, could actually be totally real pictures and not edited at all, where it could appear a little bit blue, but that's mostly just from those kinds of disturbances in the air between you and the moon, and isn't related to this term blue moon.
Yep, exactly.
Or even the phrase once in a blue moon, right? All of those things are kind of separate from the only times that the moon is actually blue, which is very uncommon.
What's also really interesting is that third full moon in a season that features 4 and the second full moon in a calendar month, those usually don't happen at the same full moon. So the next for this is we call it a calendar blue moon, but it's not the third full moon in a season that features 4.
Right.
Yeah, so that would happen on a different date. I believe it's a date next year.
I just saw a plane pass in front of the moon. Yeah, a plane flew right in front. That was awesome. I hope everybody caught that online too.
So yeah, we've got the cameras here, but the screen where we're watching the video is here. So yeah, you might see a bird, you might see a plane, you might see a spider on the front of because we've got the telescope literally pointed out a window, so that we're nice and comfortable inside. Those of you who are outside tonight in the Chicago area, it's a little windy.
It's a little windy outside. Yeah, this
was
making sure that the telescope didn't blow over.
So
we are happy to be inside today.
Oh, by the way, we want to do a little shout out. Adam, you would like us to shout out your fiance Donnie, or is it Danny or Donnie? I'm not sure how to say it. Forgive me, Danny or Donnie. I'm not sure if I'm saying it right. So a little shout out for your fiance. Congratulations to the two of you. I hope the big day is soon, and I hope it's everything you hope for. And what do you know? The sky is celebrating for you tonight.
Yeah, there you go. And hey, one thing we haven't mentioned so far today is we've got a crystal clear view. And if you've joined us for Sky Observers Hangout in the past, or just live in Chicago, then you know that that is not always the case. So we are very pleased that we can see a nice, beautiful full moon tonight, and not a bunch of clouds that are in the way. So
yeah, because we thought up until like this morning.
There was a chance.
We may not have a great
So
view.
this is a really beautiful view tonight, which we're really, really happy about. So we've kind of covered a lot of the information about, like, all right, what makes a supermoon, what makes a blue moon, right? Like, we know that it's pretty close to us when it's a supermoon, and actually this one in particular is really close to us. So, you know, we've had a couple of months here with a lot of what were technically supermoons. If we're using like the definition of like within 90%, I think that this moon right now is only like 222,000 miles away.
Actually,
really close.
We've got a great question that came in from the chat, and so it's Maiko Yamashita. So I hope I said that correctly.
I didn't even see that question was asked. Wow.
So Maiko is in 3rd grade and said, when the supermoon is 222,043 miles away right now, how many miles away is it normally? So it can be as close as about 222,000 miles. It can be as far as about 252,000 miles. So normal for the moon is anywhere in that range. There's no one normal. So you could say on average, it's about 235, 240,000 miles, but that's just an average. It can be closer, it can be farther. So there's no normal. This is normal. So it just happens to be that we have the moon at its close point at full moon.
But yeah, and I think it's a good comparison to talk about you know, how far away it is on average, right? I would say that gives us, you know, our most normal quote unquote distance for it. This is a distance that happens every cycle. You know, it will always be coming close. Sometimes perigee is, you know, a little bit closer than other times, and this one being a supermoon in particular. This is really close for during a full moon, which is really exciting.
Yeah, and I mean the close point can happen at any phase of the moon, meaning it could be at new moon, it could be at first quarter moon, it could be at a waxing gibbous, or
so perigee may not always line up with this idea of a supermoon.
Correct.
The supermoon is when it's full.
Or new,
right?
Yep. But you don't see new moons, so.
Right? Not much to see there.
Don't worry about that one.
Real close and real invisible to our eyes.
Yep. So we've I know that the chat is going nuts right now, so that is so great. And Jennifer is feeding us questions, so we can see her typing. Forgive us if we keep looking at the computer screen. So Carolyn Gonzalez, this is Audrey. I'm in 3rd grade. You're happy to learn about the blue moon and tell your class tomorrow. Excellent.
Oh, and they also said here they all thought it was going to be blue, so I'm glad you can clear that up for them. Let them know why we use that term.
Right, it is not going to be blue. So at least we don't have any little smoke particles in the sky that might give it a blue tinge. So nope, no blue moon. No blue colored moon. The term blue moon just refers to, in this case, second full moon in a calendar month. And also the term blue moon, we use it kind of in an everyday fashion as just something that just doesn't happen all that often.
Happen very often, exactly.
Yeah.
Which I think when you talk about these events makes it sound more exciting, right?
Yep.
So if anybody else has other questions specifically related to the blue moon or the supermoon, you're welcome to continue dropping them in the chat. But we wanted to take this time today in this beautiful full moon that we're looking at to think a little bit about some of the exploration that we have done on the moon, some of the trips that have happened there, some of the people that have gone there, some of the little robots that are still there right now.
Yep.
Because we've got this big old moon to look at, and we're currently in this really exciting point in with lots of different countries trying to get back to the moon, some already successfully doing that, and some looking to future missions to do that. And so we thought that, you know, what better time to think about that stuff than while looking at this beautiful big and 30% brighter moon, right? And 12% bigger.
Right.
So we're going to do a little bit of discussion on some of that stuff. And we figured, I mean, what better missions to start with than, you know, really what was starting it all back in the day, and I think what has gotten so many people super excited about astronomy And those are the Apollo missions, right? We're just hitting just over 50 years after many of those have happened. And now we see NASA trying to return back to the moon here in the next few years. So it's exciting to start with the Apollo program and talk about some of the different places that people have actually walked on the moon, the Apollo missions being the only ones that have taken astronauts there. So we're going to explore some of those different locations. We've had, 12 people walk on the moon so far. So I think we should explore those spots.
Hey, by the way, Kenyon out there in 8th, or Keon. Oh, sorry, Keon. Sorry. I thought there was an N. Keon. Maybe you'll walk on the moon, right? You're in 8th grade now. Who knows?
True, that's right.
Who knows?
Could be right around the right age for some of them.
Let's talk about Apollo 11. So Apollo 11 was the first mission to land on the moon. Should I go put the cursor over where Apollo 11 landed?
What do you think? Should we do that, or should we switch back and forth to this one?
Why don't you switch back?
Yeah, I'll show this one for now. When you're over there for adjusting the view, we can do that. But I made this little map that shows some of the locations so that we can easily go back and forth between this and the live view that we have. So we can see on here, we've got our big 11 right here, kind of in the middle on the right side. And I like this map because it kind of highlights the distribution, which we can talk about a little bit later. But first, let's think about Apollo 11 and where it has landed. So we can go back to our live view of the moon because, of course, that's what we're looking for tonight.
Yep.
But let's think a little bit about that one. So where it landed, yes, right there where the cursor is, thank you, Michelle, is just in the southwest corner of Mare Tranquillitatis, the Sea of Tranquility. One of those big, darker areas that we see on the moon. That darker rock there is the Mare that we're seeing. And so I'm curious to know, while we're looking at these different locations, why choose that spot for Apollo 11? What were they going for with that first mission? What was the real goal of that mission?
Bring back some rocks. Land safely.
Right.
Land near the equator. So the Apollo missions generally landed near the equator of the moon because that's where it's easiest to land. Those darker gray areas that you're looking at on the moon, there's our live picture from our telescope right here. And those darker areas are areas that are a little flatter. And so they wanted to make sure they landed in someplace flat or at least relatively flat. And so near the equator, relatively flat. So this area, that area for the Sea of Tranquility, it's not actually a sea. You hear that term mare.
Right.
That refers to sea because long time ago, you name it, it looks like an ocean, don't know what it is.
Right. They made these names up before the telescope
before they knew
was
what
invented,
it was. Right.
So that makes sense.
So they wanted to go to a place that would give them some interesting scientific results. And so the very first thing that Neil Armstrong did when he got off the lunar lander was he picked up a rock and put it in a bag. So if anything went wrong, they had a rock.
At least they got a rock,
They
right?
had a
We've got
rock.
some moon to bring back with us.
Yep, they got more than that, but that's all good. So
they really knew at this point that this wasn't going to be the only trip, right?
They hope not.
They were really hoping, all right, we're going to try to send a lot more astronauts up there.
Yep.
Let's make sure that we can get this landed safely. It's our first big test. And some of those traits that you mentioned continue on. So if I switch back to this slideshow here, you mentioned that they tried to do something close to the equator. They never really strayed that far from the equator. It was much easier to land there, right? I mean, you can just imagine it is literally closer than the other parts of the moon, right? And they even, with the original location for Apollo 11, chose one where the sun would be at a good angle on the time that they would be landing.
Yep.
So many factors that are going into this, but really the big one was, let's keep it easy.
Yeah.
We're landing people on the moon. That's not very easy. That's pretty tough as is. Let's keep it as easy as possible for the first one.
So one question that came up in the chat was, is the moon moving or is Earth moving?
Very good question.
Excellent question. So the moon does move.
Right. Both is true.
Yep. Earth does turn. But what you're seeing on the view tonight is our telescope doesn't track. So this particular one that we're using tonight doesn't track. And so as the Earth is turning, it makes the moon appear to move.
Right.
And so that's what you see. Now, when you see the moon slide off to one corner, that's me. That's
Yes,
I'm turning a knob or two to be able to get it back so that we get a nice view so I don't have to. So that's where I'm going every few seconds or so, is going over to the telescope over there and moving it.
But that slow, gradual movement that you are seeing, predominantly being caused by the Earth's rotation,
Correct.
rather than any movement of the moon, orbiting around the Earth.
Correct.
Of course, constantly in motion, right? Just like everything is in space. But what we're seeing is really from the Earth's rotation.
What's also really interesting is that from the Earth's rotation is the movement in this picture, as you're seeing it live, going from lower left to upper right. The moon is itself moving. In this case, it would be upper right to lower left. But
right, the moon actually goes the opposite direction.
But more slowly. So.
If we could see, if we had like some background stars, today we're exposed for the moon, so and we don't have any particularly bright stars nearby. But you would actually see the moon moving, a little bit differently than the stars did.
But that brings up something I wasn't planning on talking about, but interesting observation you just made. There are no stars in the background of this moon image. It's because our camera is set for the moon. Why are there no stars in the pictures of the astronauts walking on the moon during Apollo 11 and all the others? Because their cameras were set for sunlight. And you needed to just have your camera open for a fraction of a second. You're not going to get stars in the pictures. So if you're saying, oh, we didn't go to the moon, there's no stars in the pictures. It's because you're not going to get stars in a bright sunlit picture. When Hunter said that they went for a certain period of time when the sun was in a nice part of the sky, nice shadows and things like that.
So they could see where they were landing.
So they could see where they were landing, and it looks fairly normal. That's why. There you go.
Exactly.
All right.
That's a great one. So should we move on to our next mission, Apollo 12?
Move on.
All right, so we'll come back here so everybody can get a refresher of where we're going next. Thank goodness I drew these handy-dandy arrows. Helps me follow the numbers. So next time, we went over here. So you can kind of, to give yourself a good reference point, you can see I highlighted this crater here. It's right below there. So if we switch back over to our view that Michelle has here, you can see that crater really pointed out well, and it's just below that. Yeah, there we go, right where that cursor is. So now we're moving on to this Apollo 12 site. And, for Apollo 12, they were still factoring in some of those constraints that they were, considering with Apollo 11 when choosing another location. You can see that where they were choosing was right near the edge of another big group of mare. So it makes that easier, right? There's not so many big mountains and craters and stuff that they're dealing with at this site.
Yep.
So we have a lot of that similar stuff. But one big particular thing that they were going for here, they were trying to find some ejecta from the Mare Imbrium impact. So, all right, let's talk about how these Mare are formed, maybe, right? Because it'll give us a clue about this ejecta, I think.
Big thing from space smashes into the moon, makes a giant hole. All right.
Boom, easy. We can see they're all circular, right?
Yep.
Our idea of a crater in your head looks very similar.
Melted rock comes up from below, fills in the crater, nice and flat. Other rocks come over time, make lots of little craters. But one of the things when a big old rock smashes into the moon, rocks fly out. They wanted to see if they could find some of those rocks that flew out.
And you can actually see, some of these ejecta lines here through the telescope. I mean, especially at some of these larger craters, these real bright white lines that you see coming out of a few of the larger craters. So you can see that this ejecta is really going super far. And so what they're doing with Apollo 12 is trying to land in this location where they might be able to get some of this ejecta from the large, impact that made that Mare possible. And what is the point in trying to find this ejecta? What's special about those rocks versus all the other rocks?
Well, those rocks would help you figure out how old the crater is, and they can also help you figure out what the various different parts of the moon are made of. There's a lot of scientific information that you can learn from these rocks.
Right, maybe learning about different kinds of rocks that were there. We can also see when these craters were happening.
Yep.
If we think, oh, maybe this crater is a pretty newer one or something, then we'll have some better ideas of this sort of history of the moon, right?
Yep.
What's also pretty cool about this one is they really did learn a lot from Apollo 11, and they were able to perform like a much more precise landing location. And that actually meant that there was like some interesting stuff around them. They were able to get to the Surveyor 3 probe and actually collect some of the pieces from it and some of the samples that it had collected. So they met up with a little robot buddy.
Yeah.
While on the moon, which is so
Surveyor
exciting.
3 had landed a few years earlier. They said, hey, why don't we land near that and go walk over and get some pieces of it and bring them back and see what happens when something is left out on the surface of the moon for a few years.
Yeah.
Interesting experiment. So they did that.
Yeah, there was so many new things to learn with each trip, right? So they were always trying to choose new spots that allowed them to discover something else exciting.
Exactly. I'm going to go move the telescope again.
Yeah, so as we transition to the next one, you might notice that we've got a number missing here on our map. So we can see that the arrows from 12 are just taking a quick jaunt over right next door to 14. We don't have 13 in there. Now, this is a mission that lots of people are very familiar with, that has been covered in lots of things. You may have seen, is it Tom Hanks? Is it Tom Hanks that's in the Apollo 13 movie? So you may have seen Tom Hanks reenact this. The Apollo 13 astronauts were not able to land on the moon, right? They all made it back safely, fortunately, but they were unable to land on it when they did go up. So they ended up just using the same location for Apollo 14. They said, oh, well, we didn't make it there last time. Might as well go for the same one again. And it was really, really, really close by to the Apollo 12 site. But really kind of choosing that location for pretty similar reasons, right? Looking for more ejecta from some other impacts, seeing what other kinds of samples they can get. Every trip there is going to be super fruitful, right? If you're bringing all of these rocks back, the more data you have to collect from, the better our numbers will be. Now, one thing that did kind of happen on this one is they kind of ran into some troubles on Apollo 14. It was pretty tough for them to navigate the area that they were in, which ended up making a pretty big difference for the later missions. So what's this big jump that we see between Apollo 14 and 15 that kind of changes these significantly?
So why don't you take that one? Go ahead and.
So
it's not as flat.
Exactly, right? They got there and they were like, we don't know how to get around. We're just little astronauts. We've never walked on the moon before. It's kind of hard to make it to these different spots, right?
I wanted to say it nicely. It's like, not as flat. We couldn't get around very well. Oh.
No, you were spot on. Yeah, it was
right.
Oh, dang it. Yeah, it's okay. Hey, it happens. They learned very valuable information. And so we're like, oh, man, what are we going to do? There's all these interesting sites we want to go to. We don't want to be stuck in these mare this whole time. So we're going to send them up with a little bonus vehicle in tow. And this really started the push for getting some of that alternate transportation that we then see in some of these future Apollo missions.
So next was Apollo 15.
Yes, it is. I will make a note of a comment that's here. My middle school science teacher is here today.
Oh!
Who also was the person that gave me the first chance to teach about astronomy. When I was in high school, I student taught in his science class.
Oh.
So thanks for coming today, Nick.
How do you say his last name?
Newrider. Kind of a weird one.
Mr. Newrider. That's awesome.
And if you're really into the Grateful Dead, he's in a cover band for the Grateful Dead. So you could check that out too.
Wow.
That's new info that we usually don't have here. Very different kind of expertise in the chat.
We are going to give you the behind the scenes information that you didn't even know you wanted. So there you go. All right. I'm going to go move the telescope. Hang on.
Great. And then I'm pointing out another question that we have here from the chat. So how far away is the moon typically from the Earth compared to how far away it is on a supermoon, right? So a really good question. We're seeing this supermoon today. It's a slightly larger size, a bit brighter as well, because it is closer to the Earth in its orbit. Today, we're at about 222,000 miles away from the Earth at this moment.
Yeah.
And then, typically, how far is it typically? That is constantly changing. Mm-hmm. Of course, it covers a range. Mm-hmm. This is in the very close side of the range.
Yep.
But what did you say the average was earlier?
So there's no typical. There's an average, and there's a close and a far. So the typical average is around 238,000 miles away, but it's not like it's always at that distance and all of a sudden it's closer tonight. The moon's orbit is not a perfect circle, and so it can be as close as about 222-ish thousand miles away. Mm-hmm. It can be as far as about 252,000 miles away, and anywhere in that range is where it can be. It's just that tonight the close point happens to be at the time of full moon. So this close point has happened before, and you may not have noticed it because it might have been at first quarter moon, or it might have been at new moon, or it might have been at some other moon phase that you really didn't care. But this one gets people's attention because the full moon is bright and it's easy to see, and it's up all night, so it gets people's attention.
Right, and a great thing to observe, even if you don't have a lot of tools at home, right? If you don't have telescopes and things, nobody's going to have any trouble seeing the full moon through the naked eye. Were you seeing the question that I was saying?
Yeah, I just saw another question.
What do you think? So the question was, we've got a few people in the chat asking us to show Saturn this evening. So we are kind of set up for the moon right now. You are right that it is pretty close by. To the moon in the sky. So if you stay until the end of the show, maybe we can switch it out. We can switch it out.
It's not hard for me to switch it back. If you bear with me, I can try. You're gonna have to listen to Hunter for a little while.
It will take a few minutes. We've got the finder on there, which
I've got the finder on there.
Yeah.
So I can try. Just so you know, I'm in a room. We're in a room, and we've got the telescope pointed out the window. So
we might run into the wall before we make it to Saturn. That's the only thing I'm worried about. So we can try.
I'll try.
Fine. Yeah, we'll try.
Can you tell them about Apollo 15?
Yeah, we'll go over some other Apollo missions.
Okay.
So
hang on with us, folks.
Right.
I'll try.
Michelle's gonna give it her best shot, but first we'll continue on with our next Apollo mission. I am gonna switch over to the slides because probably most of what you'll see in the camera view will be empty sky for a while here while she's getting it focused in there. But we take it from Apollo 14 and we take a little stroll, actually kind of far away, right? We go up here to 15, and this is in a really interesting site. This is actually one of my favorite sites because this one is located kind of smack dab in the middle of actually a mountain range, what are called the Apennine Mountains. On the moon, you can kind of make it out. Sorry, my numbers are sort of in the way here. Maybe if I go back to the past slide that was just the images of the moon, you can make that mountain range out a little better. It kind of hugs right along the edge of this mare here. And so they choose to land in a very different site from where they had landed before, right? They were really confident in their abilities to land in this more particular location. They felt good about the more difficult terrain. They had experienced that with Apollo 14, and this time they had the lunar roving vehicle with them. So they decided they were going to go for this valley created by two of the mountains in this range. It sits right in between the Maria and the highlands, those lighter gray parts that you see on the moon. And they thought that this could be a really interesting site to check out. That it could be one that would provide a lot of new scientific information, right? And so we see that as we get further into these missions, that we have much more like drive to go to certain sites based on the scientific value that they have. That was always one of the sort of factors going into it. Did you get it?
Well, kind of.
We are. I will say we're sort of set up for lunar observing today.
So just so you know, we have our camera on a 4-inch telescope. This is not the the big telescope that we have upstairs.
Right.
This is a little telescope. So the magnification is fairly low. But if you squint really hard,
it's
really tiny.
Pixels. It's only a few pixels. We had this set up very particularly prepared for lunar observation tonight, right?
Yeah.
So a great view of that.
If you squint really hard, you can see it looks like Saturn has ears. Those are the rings. So if you don't see it, if you're disappointed, don't worry. It's just not a great view.
If we're doing a show about the gas giants, we'll make sure to do it through the observatory. Don't worry.
All right, keep going.
Oh no, and I wanted to shout out. We had another person here joining us today for a school science project. Peyton joining for a 3rd grade science project. So thanks for coming today. So excited to hear that. I still got your camera in view, Michelle.
I'm changing the zoom to
zoom in a little bit. Yeah, you just gotta.
Yeah, I gotta get it.
Scooch it over there. It was off
find it
to the
again.
bottom again,
Yeah,
maybe,
bottom.
and then to the right a little bit more now. I saw it for a second
I
there
did too.
earlier. Oh, there it is. Well, hey, you can make out the rings now.
Better.
For what we were going for today, I'd say that's not bad. Moon's a little easier to image than, well, basically everything else in the night sky. It's so nice and big and bright. I'll also note that, I mean, Saturn doesn't experience such a problem with this, but it is very close to a full moon right now. This like Saturn's placement in the sky is quite close to the moon, so that also can limit some of the detail you would see. But you can at least make out the rings there pretty good.
It's not terrible. It's better than I thought.
You can tell that it's really windy outside today.
Yeah.
Look at the way that, of course it's moving across the screen just like the moon was before, but it's still much more jittery.
Not only that, we've got the telescope pointed out a window.
Right.
So that also makes it a little worse. But we tried. There you go.
Yes, I'm glad that we could get it in view for everybody, and we'll have to do a show about the gas giants sometime in the future. I think that's a great idea. So if you want to see that, subscribe to the YouTube channel. Button's right down below. You'll get updates whenever we're going live. All kinds of other awesome content coming out on our YouTube.
Shout out to Peyton doing a homeschool science project.
Yes, thank you, Peyton.
I'm gonna go back to the moon.
Now, I will say we are going to return to the moon since that is our main target for the night. We got a thanks for at least trying it for us this evening. No problem. They were excited to see it, so I'm glad we could provide that at least for a bit. So yes, back to Apollo 15. So they went up there. They kind of plopped down in this mountain range. And they actually stayed on the surface for like a full 3 days. They were there for quite a long time, so they were really able to collect a lot, explore much further, of course, right? They weren't walking around. They were using this vehicle to move around, and this really, really opened up a lot of super exciting opportunities for the next 2 missions that would then take astronauts to the moon, right? One thing that I did want to share is actually in this last... Oh, here's my mirrored moon. I didn't know which way the moon was going to look tonight, so I have both of them in there. But this one actually a little bit of a relic from Apollo 15, I believe. Let me make sure that that's correct. Yes, it is from Apollo 15. So this moon rock that you're seeing here is on display just next door inside of the planetarium in our Mission Moon Gallery. And this is an actual moon rock brought back by the Apollo astronauts on Apollo 15. So that spot that we were looking at before, that mountain range, the astronauts collected this one and brought it back. And you can actually see this in our galleries right now. So if you're ever here, make sure to stop by and take a look. I feel like sometimes, just to give you an idea of how big this is, the rock's probably about this big. So a lot of the times people walk past it and don't notice it. And man, such a cool object that we have on display in the museum.
Yeah.
So I really hope that people notice it when they come in and check it out.
It's been here since 1979. So yeah, it's a pretty cool thing.
Mm-hmm.
All right.
Oh, really great question. And actually, I think this might be related to my next slide. So Bacchus in the chat was wondering how the astronauts get home from the moon, right? So we think about how they take off from here on Earth, right? We have these huge rockets that send them up into space. So what the heck do they do when they land on the moon? They got to make it all the way back to Earth. How are they going to do that, Michelle?
Well, so the lunar lander, so the spacecraft that landed on the moon, was in 2 parts. It landed as one piece, and then the top part, so it had a bottom part and a top part.
I want to make sure I got to the slide. So this is another object in our collection, not one that is out on display in the museum.
Right, yeah. You're seeing a piece from behind the scenes.
Mm-hmm.
Yeah.
Yeah, so this is an exciting one. This is one that, I don't know if or when the last time this one was out on display.
I think the last time it was on display was probably the late 1990s.
Yeah, so it's been a long time since anybody outside of Adler has seen this object, which I thought would be fun to bring today. So what's particularly interesting about this model is it even used to live at the Johnson Space Center
Yeah.
was owned by Robert Gilruth, who was the director at the time.
Robert Gilruth was a very high up person in the hierarchy at NASA, and so we have a bunch of his spacecraft models, and this is his lunar lander spacecraft model. And so you can see the lunar lander. It looks like it's in two parts. You can tell where the middle is,
You can see this kind of connection line right here that I'm highlighting with my mouse there.
So the whole thing landed, and then when they were all done, the astronauts were in the top part, and there was a rocket engine attached to that top part. It fired, boom, and the top part separated from the bottom part. And the bottom part was left. And the top part is the part that went up and reconnected with the spacecraft, the Apollo orbiting spacecraft, the gumdrop shaped piece. And they hooked back up, and the astronauts that were in the lander, or that top part of the lander, went back into the spacecraft, and that lunar lander part fell off, or they got rid of it. And then the gumdrop shaped piece was the piece that actually returned to the Earth.
You know what's so awesome, Michelle?
We have
I have a video of this happening on the moon. I had totally already baked this in to the show today. So awesome question, Bacchus. So now you will see the astronauts are inside the top portion of this right now, and you'll see it take off and fly back up. So 3 astronauts are going on each of these missions, right? 2 of them are going down to the lunar surface, and 1 of them is actually staying above, orbiting around the moon, basically waiting to catch the 2 that come back up, and then they will return to Earth. So really, really good question from Bacchus, and we can play that one more time because it is just such an awesome video to see it take off there.
What's also amazing is it's not like the camera. Actually, it's not this one. There's a different one. There's a version, I think, from Apollo 11 where it's a similar video. And when you watch it, the camera is panning upward as the spacecraft is going away. They had to guess as to
what the pan speed would be and
the pan speed would be to be able to keep the spacecraft in view. I mean, a very educated mathematical guess.
Yes.
But still.
We call that a hypothesis, not a guess, right? And so it's much more educated.
Right.
But yes, great question, Bacchus. I'm so glad that I already had that video set up and ready to go. I think
Bacchus,
this one was
Bacchus
from...
knew. He knew that we were gonna...
He must have. I mean,
that.
It was literally my next transition was talking about this. So there's got to be something going on there. So should we? Well, here, let's return to our lunar view. Next, we're gonna move back to talking about our final 2 Apollo missions. Is all we have left here with 16 and 17.
By the way, can you realize Bacchus, 8 years old? 8 years old.
I know, it's a really great question.
Questions.
It's a really great question.
We are so happy to see so many kids joining us tonight. Thank you.
Yes, that really is awesome.
Parents,
and taking it back with you to school and stuff, that's really
parents, thank you for turning us on and
letting them stay up late. It's totally worth it. It's totally worth it.
So thank you. All right, where are we at?
So we can see next up, we covered Apollo 15, and we started talking a little bit about some of the Apollo 16 stuff. I can't remember which flight that video was from. But if you see next, we'll take it from those Apennine Mountains here in the sort of upper part of the moon. A little stroll down, actually back pretty close to our Apollo 11 site here. Now, one thing that you'll notice about this site is, all the other ones are really located in these darker areas in these mare. This one's really smack dab in the middle of the highlands. So let's get back to our view of the moon and check out those highlands.
Yeah, let me move it a little bit.
And do you want to go back full screen for us here really quick too?
Sorry. I will do that.
So one important thing to know in why they wanted to land in this like purely highlands region of the moon so badly for this one and really get a chance to do that is we're seeing very different type of rock here. So Michelle talked about how the mare were formed earlier, right? These really large impacts. These highlands region that we see, that lighter part, is basically what the whole moon would look like if we didn't have those big impacts creating the mare, right?
Yep.
So they went to this site in the hopes of finding some really old moon rocks, right?
Yep. Mountains, rocky areas. They're getting better and better at landing. Still near the equator, but definitely getting better at landing in a little bit more challenging locations.
Right. They're more confident in what they can do. They saw the capabilities of their little moon car they were driving around with Apollo 15, right? They'd gotten the chance to test that out a bit. And so they wanted to challenge themselves more, look for some of that old rock, and really try to start to uncover this early history of the moon, right? Way before, obviously, any of us were around, right? Billions of years ago, when the moon is forming around the Earth. And that's really what they were trying to uncover. It wasn't necessarily the most fruitful location. They ended up getting a lot of stuff kind of similar to what they already had. But they'd also already gone, 1, 2, 3, 4 times before that to make sure my math was right.
Yep.
Had to make sure, so understandable that they were finding some similar rocks.
Yep.
But yeah, that's really the point of that new location, is trying to find some of that older stuff and uncover the history of it, which really still many competing theories about the formation of the moon. It's something that we're still working on really narrowing down. Right?
The latest, based on the scientific data from the rocks that the astronauts brought back, the leading theory, and I'm not using theory as in guess, I'm using it as in scientific data backs up this theory.
Right, it's a theory. We can't prove it. We can't go back and see the moon forming, right? So it will.
But the current one is that a Mars-sized object hit the Earth, either a direct hit or a glancing blow. Rocks splashed out and essentially formed the moon. So the moon formed from an impact of the Earth very early on in the Earth's history.
Mm-hmm.
So that's why Earth rocks and moon rocks are surprisingly similar.
Mm-hmm.
They shouldn't necessarily be so similar if the two objects formed completely separately, if they formed absolutely separately. So we have a show here at the Adler called Imagine the Moon.
Yeah, which really covers basically exactly that.
Yeah, if you want to learn more about that, come on and see it. It's a really good show. I really
like that one too. It's one of my favorites.
Yeah.
So now, as we move from Apollo 16 to our final Apollo mission, we go to 17, which takes its way kind of back up to the top there, right in between these two large mare. So their goal with this one was really to return to a pretty similar area that Apollo 16 was going for, right? Find some of that older rock that they had some difficulties finding at the Apollo 16 site. And so that is why they choose this location for 17. It was a highlands region that still wasn't too tough to land on. Some of the spots are pretty brutal and would be very tough to traverse and especially to land on. And so they picked one that was a good middle ground between it, and I mean was a pretty smashing success.
Yeah,
they found a lot of well, yeah, I guess not so smashing. They weren't in one of the big impact craters, but really collected so many samples. Really found a lot of the stuff that they were looking for, and was really, I mean, honestly, just a fantastic way to end off these Apollo missions.
Fast forward from these very successful Apollo missions, which all landed near the moon's equator. Fast forward to last week.
Mm-hmm.
And
I like that fast forward.
An extraordinarily amazing accomplishment from India, soft landing a spacecraft at the South Pole of the moon.
Mm-hmm.
And I can't stress enough how difficult that was. And they did it. And they've got a little rover that's
I was going to say, yeah, I wanted to show off. These were some of the first pictures that they had released from the surface as the rover was embarking on its long journey. I think since I put these in, they've got some pictures from the rover looking back at the lander as well. But many more to come. Lots of really essential scientific information to come from this mission. And I mean, what a wonderful success from now only the fourth space agency to successfully land on the moon, right? So we had us and Russia battling it out in the 60s and 70s, trying to get there quick, sending lots of things to the moon, and then kind of a pretty big lull in lunar exploration, right? Which is really kicking off again right now with the Indian Space Research Organization making it there. We also had just within the last couple of years, the Chinese National Space Administration sending stuff to, again, very unique and new, exciting locations on the far side of the moon.
Yeah.
The side that we do not typically see, that we don't, not typically, ever see from here on Earth. Extra unnecessary descriptive words.
It's okay.
So we can see all of these things really exciting happening. And I would love for you to talk a little bit about the South Pole part of this and why they chose to land down there. I'll adjust the telescope. Let's see if I got as good of a skill at it as you do.
So the near knob, turn it to the left.
Perfect, thank you.
And the other one, fiddle with it in whichever direction.
Needed.
There you go. All right. So the South Pole of the moon is extraordinarily interesting because there are several very deep craters, and those deep craters contain water ice. There have been several spacecraft missions that have helped us be very confident that that water ice is there. And these deep craters, they never see sunlight on the floors of the craters, so the ice stays there. That could be a resource for us when we send people to the moon, where NASA wants to land people on the moon in the next several years, is at the lunar South Pole. Yeah. And so there's also a variety of reasons to go there besides because could be water ice there. The South Pole, there are portions of areas near some of these taller crater rims that see sunlight almost constantly. So the rest of the moon, you'll get a period of sunlight for 14 days and a period of darkness for about 14 days. Well, there's a few of these areas near the South Pole that the crater rims are high enough that at least they get sunlight most of the time, if not all the time. And so that could be useful as an energy source, using solar energy to power a lander spacecraft and power a little any of the equipment that they've got there and everything, the scientific equipment, keeping people alive, all that kind of stuff. So so there are a variety of reasons that we will send people to the South Pole. So this information from the India spacecraft Chandrayaan-3, that information is going to be incredibly valuable because it's the first time we will have seen the South Pole of the moon up close on the surface.
Absolutely. And so we've already started at NASA. They've already started working their way back. Many of you may have seen, I mean, obviously lots of news was out about it. Artemis 1 launching last year or was that
November?
Earlier this year?
Okay, last November.
I was going to say it was right at the end of last year, right? Man, time sure does fly when you're having
know.
fun, huh? When you're looking at space so dang often. Got my head in the clouds.
So to speak.
Well, not today. But these were some images from that first Artemis launch. Well, I guess here, let me move our faces out of the way for a second. So it taking off, and then I love that image of the Orion spacecraft with the moon and the Earth in the background. Just fantastic. So that's Artemis 1. This is an unmanned flight. We've got Artemis 2 coming up next, which will have astronauts on board. They will not land on the moon.
Correct.
They will go and orbit around, just like Artemis 1 did. But always good to do tests with people on board.
Yep.
And then with the plan of Artemis 3 being the return of astronauts walking on the moon.
Yeah. So Artemis 2 timeframe 2024, 2025. Landing people on the moon. Hard to say, 2026, 2027, something like that.
Yeah. These things take time.
Yeah, we need Artemis 2 to go well and learn from that to be able to really nail down the schedule for Artemis 3. So,
and especially when you're dealing with these spacecraft that do have people inside. Yep. Particularly important to be extra careful. Well, that covers our exploration of the moon from past to present. It has been so great getting to have such a clear view of the full moon all night. Yeah. If anybody does have any final questions for us this evening, drop them in the chat for us. We'll hang around and answer those, of course. But I think that's a lot of our prepared material for the night.
Yeah.
Thank you, everybody that is joining us today. We've gotten so many great questions this evening, especially for a topic that was honestly a little confusing. You're like, all right, I don't see a Superman logo. The moon's not blue. What's making this so blue and super?
It's just, oh my goodness. Oh, no Superman logos. No.
So it was a confusing topic, so I'm glad that we could.
Ooh, Jim Walsh. Does the moon rotate at all on its axis? I can do a little demo. I'm going to roll back just a slight bit. Okay.
And to give folks an idea like why this question might be asked, is you might be wondering, like, we see the same image of the moon all the time.
We see the same side of the moon. You go, wait, it must not rotate because I see the same side. If the moon did not rotate, then as the moon goes around the Earth, I'm going to try to do this with the camera. Let's see. I'll use my phone just as, pretend this is the moon. Pretend this is, you get to see my cats. I'll do the backside. So pretend this is the side of the moon that always faces the Earth. If the moon did not rotate, it would always face the same direction. So I'm looking at a wall over there. The same side would always face the wall. So by the time if the moon goes around the Earth some more, you would then see this side of the moon. If we go over to the other side of the camera facing that same wall, you would see the back side of the moon. It coming around this side, you would see this side of the moon if it did not rotate, because it does rotate. Now watch what happens. I'm going to, let's see, do me a favor, hold that. And pretend this is the Earth. Pretend this is the Earth, all right? So this is the side of the moon that faces the Earth. This is the Earth. So it comes around. Now the moon is facing this wall. Now it's facing that wall. Now it's facing this wall. Now it's facing this wall. My moon just did this in the time it took to go around the Earth once. If it didn't, it would look like this.
So we would see the backside because there's still people on this side of the Earth, right? There's people all the way around.
So this side, then you'd see this side, then you'd see this side, then you'd see that side.
Right.
Okay?
So it does rotate on an axis,
Yes.
but it rotates in the same amount of time that it takes to complete one orbit, making it tidally locked.
We've got another question from Lego Craft McDonald. When is the next lunar eclipse and solar eclipse happening? So,
another great segue. Thank you guys. Oh, just wonderful this evening.
So the next solar eclipse is Saturday, October 14th, 2023. We will be on again live during the solar eclipse. We're going to start our broadcast at 10:15 in the morning. If it's clear out, we will be pointing a telescope at the moon and showing you the eclipse live. Cross your fingers. It's just as clear on that date as it is,
as
we've got right now. So solar eclipse Saturday, October 14th, 2023 for Sky Observers Hangout, 10:15 a.m. Central Time. And we'll run our show till about, we'll run Hunter and me on screen till about 11. If it continues to be clear out, Hunter's going to stay on and keep pointing the telescope at the sun. And so we're going to stay on, answer questions in the chat. We just won't have us on the camera at that point, but we will have the camera pointed at the eclipse.
Yes, so, we will be live. Rain or shine, though.
Rain or shine, yep.
Can't guarantee that we'll have a telescope view, but we'll be here chatting about solar eclipses with everybody that joins.
Yep.
And, of course, always help and let you know how you can view it at home, too.
Exactly.
Because if our conditions are bad, hopefully yours are good.
Right. And then the next lunar eclipse is March, I think it's 13th. I think it's March 13th.
I was just looking at it. It's March 13th, 2025. Now, that is a total for here in Chicago and across the United States. Of course, these are very dependent on where you are joining us from today. So if you do happen to be in Chicago, then those dates will line up for you. But I would really encourage you to check out Time and Date. That website is really great for finding information about eclipses based on your location, too.
There will be a couple, 2 or 3 lunar eclipses in between now and then, now in March 2025, that will be eclipses where the moon will only pass into the lighter outer shadow of the Earth, and it will be very difficult to tell that there's even an eclipse happening at all.
Right, very tough to see. So those totals, you'll see the moon very clearly change colors, right?
Yep. So you'll see a mention, I'm sure, of a penumbral or a Earth's outer shadow lunar eclipse, 2 or 3 of them between now and March 2025. it's one of those, if you don't notice a difference, it's okay. We probably can't see the difference
Mm-hmm.
either. So those aren't as spectacular as a total lunar eclipse, but
Yeah.
that one is March of 2025. Oh gosh, we've got Nature Fan. Thank you very much, Nature Fan. Jennifer put your comment into our behind the scenes screen right here.
Yes,
so.
I'm glad that you enjoyed coming to us today. And, a good reminder, they're a new subscriber.
Yeah.
And I would encourage anybody who is here today who enjoyed our broadcast to subscribe to the channel below. You'll be able to get updates whenever we are going live. For Sky Observers Hangout, but also see all the other great content that we have. Some series like Skywatch Wednesdays and things.
Yep.
That will really give you a ton of awesome astronomy content.
If you like us, give us a thumbs up, because that helps other people find our videos as well. Not just Sky Observers Hangout, but all the rest of the great, amazing things that our colleagues put together here at the Adler Planetarium. We're so happy you joined us. Let me do one more telescope. One more adjust.
Well, while you do that, I do want to say that I know we have folks joining from all over today, but if you are in the Chicago area, you should come and visit us in person at the Adler Planetarium. We have lots of opportunities for you to look through our telescopes, including the Dome Observatory right upstairs. If you would like to keep up to date with that information and those kinds of opportunities, you can join our Facebook group, Scopes with the Adler, where we update all the different places we're going to, but also give like weather updates and confirmation on if things are happening or not. So that's a really good place to keep an eye on things. We'll also have Jennifer posting in the chat for us a little feedback survey. If you have any feedback for us, whether it's good or some improvements that you think we could make to the show, we love to hear it. If you've submitted it before, feel free to do it again with your new ideas.
And we really do read it.
We really do.
Read
Another
it.
one that we really love that comes through there is some of the episode recommendations.
Yeah.
So you can put in like ideas that you might have for episodes and things. It's a really good thing to fill out and really helps us out a lot. So if you have the time, we appreciate it.
There was one that came through we were talking about recently. Like, oh, that's a good idea.
Mm-hmm.
So yes, we definitely appreciate your ideas. It needs to be something having to do with observing the sky. So yes, while we know you probably would want a show on black holes, we can't show you black holes.
Right.
So we can't do that topic. But if it has something to do with observing the sky, something you might be able to check out, hey, let us know. We would love to get those ideas.
Other than that, what a great night of observing.
So good. Go
Just-
outside, enjoy the view, folks.
Yes. So this full moon is just starting, right?
Yep.
We pretty much caught it. It rose at 7:45 right before we started setting up, or right around when we started setting up. So we're catching it early in the night. Get out there, observe it. Let us know if you think you can tell that it's 30% brighter than the smallest moon. Maybe not. If you take any awesome pictures of it, make sure to tag us. Use our hashtag #lookup.
Yep.
When posting any of your awesome celestial views that you might get, whether of the moon or of anything else. And other than that, clear skies to all, and keep on looking up, right?
And we hope to see you at our next show, Saturday, October 14th, 2023, 10:15 a.m. Central Time, solar eclipse.
So
and
awesome.
if you happen to want to come down to the Adler that morning, please do. Information's on our website. We hope to see you soon. Thank you so much, everyone. Have a great night. Keep looking up.